Hello everyone, welcome back to LMG. Today I am back with another video where I'll be discussing the PYQs of NSEP for the chapter Center of Mass from the year 2003 to 2025. So there are very few questions from this chapter, roughly 14 questions, but the quality of the questions is very good from this chapter. So let us begin. So the first question is the best question from this chapter. So it says that a carpet of unit mass and unit length is laid on the floor. One end of the carpet is bent back and pulled backwards with unit velocity, just above the part of the carpet that is still at rest on the floor. So we have to find the speed of the center of mass of the moving part and the minimum force needed to pull the moving part. So there are two parts in this question. So let us begin with the first part. So the situation is something like this. This end is being pulled by a velocity 1 meter per second, and let us assume that this is the origin. Okay, so if at any instant the amount of rope that the amount of carpet that has been folded is equal to x, then this distance must also be equal to x, right? Because this part was here before being folded, so this length and this length must be equal, and I am assuming that this curved part length is very small, so we can neglect it. So this must be x and this also must be x. So this total length is equal to 2x, right? And on moving further also, the length of the folded path can be assumed to be x. If even the rope has reached here after some time, then this will be x and this will also be x. So at any point, the coordinate of the end point of the rope is equal to 2x, and I know that d by dt of 2x is equal to v, right? Is equal to 1 meter per second. Okay, so now we have to calculate the velocity of the center of mass. Okay, so there is a very interesting concept that is being used in this question, that if you see a material point, I will define as any point which is present on the rope. So if I take a material point anywhere, then that also must be moving with the same velocity, right? Because the carpet is not getting slacked, so the distance between this point and this point must remain same. So if this is moving with 1 meter per second, then this also must move with 1 meter per second. But center of mass is not a material point. Remember, center of mass is the center of mass just tells us about the average parameters of the body, right? It is not a material point which is present on the carpet. So the center of mass will be located at a distance of x plus x by 2, right? But it won't be a material point, because the material point at x plus x by 2, which is 3x by 2, that will be moving with 1 meter per second. But the center of mass, which is present at the same geometrical location, but it is not a material point, it might not move with 1 meter per second, because there is no constraint that the distance between the end point and center of mass must remain same, right? Because after some point, the end point will reach here and the center of mass will become something else, right? It will reach here. Earlier it was here, now it has reached here. So there is no constraint that the velocity of the center of mass also must be equal to 1 meter per second, because it is not a material point. So we can find the center of mass velocity using the fact that it is located at 3x by 2. So differentiating the position of the center of mass at this instant will give us 3 by 2 dx by dt, and we know that dx by dt is equal to v by 2, right? It will be 3 by 4v, which is equal to 3 by 4 meter per second. Now, many of you might be confused that why we have chosen d by 2x of dt to be v, right? Because I earlier claimed that every material point on the rope will be moving with the same velocity v, right? This will be moving with velocity v, this is moving with velocity v, this is moving with velocity v. But we wrote that d by dt of 2x is equal to v, right? Why? Why can't we write that d by dt of 1.99x is equal to v? Why can't we write this? Because this will give us a different final solution, right? So this is because the 1.99x is not a material point, it is just a coordinate. Let us understand this. If you have a piece of bread that is kept vertically, and the length of the bread is given as a function of time, and let us denote it by L of t, and let us denote a point which is at 0.9 times of this length, right? So if at some time it is at 100 centimeter, then this 0.9 times of LT would be at 90 centimeter, and from the top this would be at 10 centimeter. Now if you eat 10 centimeter of this bread, then the total length of this bread will decrease, right? This will become 90 centimeter, and now the 0.9 times of LT would be at 81 centimeter from the base, right? So this point which you had taken as 0.9 times of t was 10 centimeter away from the top, which is somewhere here. But now the 0.9 times of LT is 9 centimeter away only, right? This is, the diagram is not representing the true lengths. There is only 9 centimeter left. So 0.9 LT is not fixed to a specific point, right? Because we saw that 0.9 LT became a point 9 centimeter away from the top, right? Earlier it was a point 10 centimeter away from the top. So this point is not being always represented by 0.90, right? But if you see, the LT point is always representing the same point. So we can say that the rate of change of LT is equal to V, but we cannot say that rate of change of 1.99x or 0.9x is equal to V, because it is not representing a single point. It is just a coordinate which is representing different points at different times. So hope this is clear. So I have another method for solving this question. So if the instantaneous positions of this folded length is xs and the pull end is xp, then the length of this rope would be given as xp minus xf, right? Because this is the moving part. This part is occupying from xf to xp, so this will be the length. Now we know that this length dl is changing, which is represented by dl by dt. It is changing because this end is moving with v, and we are assuming that this end is moving with u. So dl by dt would be given by v minus u, because this end is moving with v and this end is moving with u. And also the length is increasing because some part of the rest length is moving into the moving part, right? This some part is moving into the above part, and that is happening with velocity u, because this end is moving with u. So we can write dl by dt in two ways, and those two ways should be equal because dl by dt should be equal. So we get v minus u is equal to u, which gives us that 2u is equal to v, or u is equal to v by 2. So this end, folded end, is moving with 0.5 meter per second. And we know that the x coordinate of center of mass is given as xp plus xf by 2. And if we differentiate this, then we'll get that d by dt of x of center of mass is equal to velocity of center of mass is equal to d by dt of xp plus xf by 2, which is equal to v plus u by 2. And since u is equal to v by 2, we'll get 3v by 4, which is the same as we got in the first method. So this was a very nice question. So we have completed the first part, and the main point is that this end won't be moving with the same velocity, because if this end is moving with the same velocity, then the length of this part won't ever increase, right? Because gl by dt would become equal to 0. If this part is also moving with v and this part is also moving with v, then how can the length change? So this part, the folded end, must be moving at a velocity different than v. So the force analysis we have to do, minimum force needed to pull the moving part. So whenever force is given as the change in momentum, right? And momentum can be written as mass into velocity. And since velocity of every part is constant, every material part is constant, so applying the chain rule or the multiplication rule, we'll get since velocity is not changing with time, then this part is 0. So the force will be due to the change in mass, right? The new part of rope that is coming, and the new part of the rope that is coming due to this fold. So this fold is providing new mass into this moving part with velocity u, as we already saw that this has velocity u, and that new part has velocity v, right? That new part which is getting added into the moving part at a rate u has a velocity v. So dm by dt should be equal to u and the velocity is v. So this will give us the answer as uv, and since u is equal to v by 2, then we'll get v square by 2, which is equal to 0.5 Newton. So this was a very nice question. Moving on to question number 2. This is also a nice question. So a mason lays 4 bricks to make an arc so that a portion of each brick protrudes over the one below. So we have to determine the maximum lengths of overhanging parts when the bricks are still in equilibrium without motor. Okay, so length of each brick is 1. So this kind of question you must have seen before, that we have to find the maximum length of the overhang. So in this question, the funda is that the vertical line through the center of mass of top bricks. So if there were more than one brick, then we have to take the combined center of mass. So the top k bricks must lie within the support region of the brick below. So if there are k bricks above this brick, then the combined center of mass of those k bricks must lie in the support region of the brick below them. So if the center of mass line lies inside the support, then the group is stable. The group of k bricks is stable. And if it lies exactly at the edge, then that is the limiting case where we have maximum overhang. And if the center of mass of the combined k bricks is beyond the edge, then the system will topple. So the condition for limiting case gives the general formula. So the maximum overhang for the k bricks is L by 2k. What this means that if there is only one brick, then this maximum overhang will be L by 2 because k will be 1. This overhang will be L by 2 multiplied by 2 because there are 2 bricks. So this will be L by 4. And if there is another brick, then this will be L by 2 into 3, which is L by 6. So we can prove this by induction. We can prove this easily by induction. So in induction, there are two assumptions that for n is equal to 1, the overhang is L by 2. For n is equal to k, overhang is L by 2k. So these are assumed to be true, right? And if we can prove that to prove is that for n is equal to k plus 1, the overhang should be L by 2 times of k plus 1. This we have to prove, right? So the situation is something like this. So assume that this is the k plus 1th brick and this is the kth brick. So this will be the k minus 1th brick and so on. And these will be a group of these dot 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 dot. These will be total k bricks, right? So we have assumed that it is true for this group of k bricks that this maximum overhang will be equal to L by 2k. So we can assume that this group of k bricks is a single point located here, because the center of mass of group of k bricks should be located at the edge of k plus 1th brick for maximum overhang. So this dot is k bricks. This dot is representing the position of k bricks. Also, the center of mass of this group of k plus 1 bricks should be located at the edge of this k plus 2th brick for maximum overhang. So this point is representing the position of k plus 1 bricks. Okay, so the center of mass of this individual k plus 1th brick would be somewhere here at a distance of L by 2 from here, right? This will be L by 2 and this will be L by 2. Because the center of mass of an individual brick must be at the center of this length, right? Center of length of individual brick. So if I assume this as origin, then I can write that the position of this center of mass with reference to this origin would be, so the mass of this k plus 1 individual brick is m at 0, because I have assumed this to be at origin, and the mass of this brick, this group of k plus bricks that I have represented by this point, is at a location of L by 2. So L by 2 multiplied by km divided by m plus km, mass of this brick and the mass of group of k bricks. So this will give us that the position of this k plus 1 bricks point is at a distance of L by 2 km divided by m k plus 1. Cancelling out m, I will get that it is equal to Lk by 2 k plus 1. So this length I have obtained. Now I have to find the overhang length. That will be equal to L by 2 minus Lk by 2 k plus 1. This will be the overhang length, and this comes out as L by 2 k plus 1. So I have proved this. So in the original so we have proved by induction that this formula is true. So the answer for this question, since there are 4 bricks, so the maximum overhangs will be L by 2, L by 4 and L by 6 respectively. So moving on to question number 3. A metal sheet 14 cm by 2 cm of uniform thickness is cut into 2 pieces of width 2 cm. The 2 pieces are joined and laid along XY as shown. So the center of mass has to be found out for this arrangement. So there is some missing information that the mass ratio of this and this is 4 by 3. So if this is 4m, then this is 3m. So that means that since width is same, then the length should be 4L and 3L, right? Because they have uniform density. So this will be 3L. So since the total length is 14, so this length will be 4 by 7 times of 14, which is equal to 8 centimeter. And this length should be equal to 3 by 7 times of 14, which is equal to 6 centimeter. So the center of mass of this part will be here, right? So since the width is equal to 2 centimeter, then the x coordinate of this should be at the middle. So this will be, x coordinate will be 1. And since total length is 8, so this y coordinate should be 4. So the center of mass of the first part is 1, 4. And similarly, you can find out that center of mass of second part will be 5, 1. Since after 2, there should be an increment of 3 because the total length is 6. So 2 plus 3 is 5 and the width is 2. So at the center, the y coordinate will be 1. So now we can find the center of mass. So this part has mass 4m. So x coordinate of center of mass will be x 4m multiplied by 1 plus 3m multiplied by 5 by 7m, which will give us 15 plus 4, 19 by 7. And y coordinate of center of mass will be 4m multiplied by 4 plus 3m multiplied by 1 by 7m, which will give us 19 by 7 again. So the correct answer will be B. Question 4 says that a uniformly thick plate in the shape of arrowhead has dimensions as shown. So the center of mass we have to find out. Okay, so if this would have been a triangle, then we know that center of mass of uniform thick triangular sheet is at the centroid, which divides the median in the ratio 2:1. So this is given as 6 centimeter. This is given as, the height is given as 9 centimeter. So it will be at a point which is dividing this median in the ratio 1:2. So we can find out that this length will be 9 by 3, which is 3 centimeter. And this length will be 6 centimeter. And the mass of the negative mass part, which has been removed, it has a height of 3 centimeter only. And the base is same, 6 centimeter. So the center of mass of the removed part would be at a height of 1 centimeter from the base. So we can use the negative mass concept, and from that we will get that. Also we need to find the mass, relate the mass of these two. So if the mass of this is m, and since the density is same, so mass by area is half into base into height, should be equal to the density of this. So if the mass is m dash for this, area is half into 6 into 3, which will give us that m dash is equal to m by 3. So now I'll apply the center of mass with negative mass formula. M into 3 minus m by 3 into 1 by m minus m by 3, which gives us 8m by 3 by 2m by 3, which is 4 centimeter. So since this is 3 centimeter, it will be 1 centimeter to the right of O. Option D is correct. So moving on to question number 5, it says that Sachin and Kapil of mass 55 kg and 65 kg respectively. So assume that this is Kapil and this is Sachin. and the boat has mass 100 kgs. It is 3 meters long. So Sachin walks down to Kapil to shake his hand, so the boat gets displaced by. So since there is no external force, that means that the center of mass of this entire system should remain constant, right? In both the cases. Because there is no net external force, so center of mass will remain same. So what I will do first is that I will assume the boat to be a single point located at the center of mass of the boat, which will be at 1.5 meter from both the persons. And after, in the second case, Sachin and Kapil are on the same end. So Sachin plus Kapil are here. And since the mass of Kapil is more, so it is obvious that the center of mass will be somewhere here, right? The center of mass in this case should also be here. So for this, the boat mass must have moved somewhere to the left, right? Because the mass here has increased. Earlier this was 55 kg, this was 65 kg. Now this is 120 kg. So this 100 kg point, which we have assumed to be the boat, has moved somewhere here. So first let us find out what is the position of the center of mass in both the cases. Center of mass can be found out using this formula, 65 multiplied by 1.5. Since it is on the right side of the y-axis, this is the y-axis, I am taking this as the reference, and this is 1.5 kg to the left, divided by 65 plus 55 plus 100. The center of mass of the boat is located at the origin only, right, on the y-axis. So this will be 100 multiplied by 0. So there will be no contribution. So the center of mass on calculation comes out as 0.6818 meter. So this distance of the center of mass is 0.6818 meter. Sorry, 0.06818 meters. So center of mass in this case should also be 0.6818. So notice that if the boat has moved d distance to the left, then the new center of mass formula would be, so this distance would be now 1.5 minus d meters. So 120 into 1.5 minus d minus of, this has moved d to the left, so minus of 100 d by 220. This is 220 total mass. This should be equal to 0.06818. So on solving this, we get that d is equal to 0.75 meter. So the correct answer is option B. So some people forget that the person would also shift by d, and so they get the wrong answer. So question 6 is an easy question. Consider a uniform square plate of side 2L made of wood. A semicircular portion is cut out and attached to the right as shown. So we have to determine the center of mass of this arrangement. So here first what we will do is that we will relate the mass of all the shapes, right? So the original square has an area of 2L multiplied by 2L, right? Because each side is 2L, so this will be 4L square. So assume that original square has mass of M. So original square will have density of mass by 4L square. And since the material is same for all the shapes, so the density will be same. So the mass of semicircle, which has been cut and then put here, would be the area of the semicircle, which is pi into L square by 2 multiplied by the density, so m by 4L square. So this comes out as m multiplied by pi by 8. So if the mass of the square was m, then the mass of this semicircle is m pi by 8. So now we calculate the center of mass. So we know that for semicircular plate of radius L, the center of mass lies at a distance of 4L by 35 from the center. Right, center is this for the semicircle. For the negative mass, it will be 4L by 3 pi from here, and for the mass that has been added, it would be 4L by 3 pi from here. So assume that this is the origin, the center of the square. So center of mass I will start writing. The center of mass would be the mass of the square without this cutout portion is m multiplied by 0, because the center of mass will be at 0. I am writing only the x component, right? Because y component will be 0. So m multiplied by 0 minus of, since this has been removed, so the mass is m pi by 8 multiplied by, so from the center, from the origin, it will be L minus 4L by 3 pi, right? Because this length is L minus 4L by 3 pi, since this is 4L by 3 pi and this total is L. And this length from the center would be L plus 4L plus 3 pi. And total mass would be m only, since this is negative and this is positive, so it gets cancelled. So the final answer would be minus m pi by 8 L plus m pi by 8 4L by 3 pi plus m pi by 8 L plus m pi by 8 4L by 3 pi divided by m. Since this is negative and this is positive with same magnitude, so this gets cancelled. Final answer would be 2 multiplied by pi by 8 multiplied by 4L by 3 pi. So this 8 and this 8 will get cancelled and we will be left with L by 3. So the center of mass is L by 3 to the right of this origin, right? So L by 3 comma 0. So moving on to question 7, it says that identical point masses are placed at n minus 1 vertices of regular polygon of n sides. The vacant vertex has a position vector a and with respect to the center of the polygon. Therefore, the position vector of the center of mass of the system is. Okay, so for a regular polygon, assume we are taking some regular polygon like this. This is a hexagon. So for regular polygon, the center of mass would have been at the center of this shape, right here. But if we remove one point, then the center of mass will get shifted in this direction, right? So we can write the center of mass of this system using the negative mass concept. So for all the n points, the center of mass would have been at the origin. So for n multiplied by m, the center of mass is at origin. I am writing in vector form, so no x and y components. And for this point, for a point, the center of mass is the point itself. So that point has been removed. So minus of this point has a vector a dash, right, with respect to the origin. Origin is at center only for our reference. So minus of m multiplied by a vector, and total remaining points are n minus 1 multiplied by m. So the final answer would be m a dash minus sign n minus 1 multiplied by m. M gets cancelled and we get the answer as option B. Moving on to question 8, it says that 4 point masses are placed in a plane so that the center of mass is at 1, 1. 3 of them have mass m each and are placed at 0, 0, 2, 0 and 0, 2 respectively. So the fourth point has a mass of 2m, and it is displaced from its initial position such that the center of mass has changed and it moves to 2, 1. So let us write the initial center of mass. So initial center of mass, since the center of mass is only changing in the x coordinate and the y coordinate is not changing, so we can say that the center of mass has changed. The displacement of the fourth particle would have also been parallel to x-axis, right? Because if displacement is in the y direction also, then the y-axis, y coordinate of the center of mass should have also changed, but it is not changing. So A option would be correct. Now I will write the center of mass formula for x coordinate. So m multiplied by 0 for this, plus m multiplied by 2 for second, m multiplied by 0 for third, and the fourth particle has mass 2m. And let us take the x coordinate x1 for initial. Total mass is 5m, and initial center of mass for x coordinate is 1. So this gives us x1 is equal to 1.5 units, right? Then finally all the first 3 points are at the same position only, and the fourth point is changing its location. It has changed to 2, which gives us x2 as 4 units. So the displacement is 4 minus 1.5 units, which is 2.5. So option C is correct. Option B is wrong because the displacement is 0 degrees with x-axis, right? So A and C are correct. This was a 6 marker question. So question 9 is also easy. A uniform rod ABCDAC. So ABCDAC is bent in the shape of a kite. If a point X along the line AC is the center of mass of the structure, then distance AX is asked. This distance is asked. Okay, so since the kite has this side equal to this side and this side equal to this side, so this would also be 1 meter, and since this is a right angle triangle, so Pythagoras theorem will give us that this side should be root 3 and this side should be root 3. Okay, so for we can divide this shape into 3 main parts. First is this middle rod, second is this root 3 rod, which is at the bottom also. We can easily multiply it by 2 because there is symmetry, and third is this 1 meter rod, which is at the bottom also. So first we will write the center of mass of this root 3 part. So root 3 lambda is the mass of this rod, if lambda is the mass per length quantity. Then root 3 lambda would be the mass. Sorry, there is a misprint. This would be root 3 by 2 because the root 3 is the length. So on this, the center of mass would be at a length of root 3 by 2, and then we have to take the projection on x-axis, right? So on the x-axis we are taking cos 30 projection and multiplying it by 2 because there is a rod at the bottom also. Then this 2 meter rod would have mass of 2 lambda, and we multiply it by 1 because the center of mass would be at a distance of 1 from A. Then this final rod has a mass of lambda, and then this length from here would be half. So this is the half, and then we are taking on the projection cos 60. So cos 60, this length is half cos 60, and then we minus it from 2 to find this length from the origin, since A is the origin here. This is this term, and multiplying it by 2 because it is at the bottom also, and then finally we divide it by the total mass. So finally we get 1.08 as the answer. In NSEP you get calculator, so you can easily calculate. Question 10 says that a sphere of radius r is made up of styrofoam, which is a light polystyrene material. It has a cavity of radius r by 2. So this is the cavity. The center of the cavity is situated at a distance of r by 2 from the center of styrofoam sphere. So this distance is r by 2. the cavity is filled with a solid material of density 5 times that of styrofoam. Then we have to calculate the center of mass from the center of this big sphere. Okay, so since the density of the filling material is 5 times and we had removed this one time, so we can assume that this has been filled by a, so we can assume that this shape is a combination of this full sphere of mass m1 and density rho and another sphere 4 rho mass m2, right? Superposition of these two shapes. We are neglecting the cavity part because instead of 5 times the density, we have taken 4 times the density. This would reduce the number of calculations. Okay, so if this mass is m1, so m1 can be written as rho times the volume 4 by 3 pi r cube, and m2 can be written as 4 rho multiplied by 4 by 3 pi r cube by 8, right? Because the radius is half of the total bigger radius. So m2 will be m1 by 2. So now we can write the center of mass. So since this is the origin, we are assuming this to be origin. So the center of mass of the bigger sphere is at 0, 0. So m1 multiplied by 0 plus of m by 2 multiplied by r by 2 divided by m1 plus m1 by 2. So this will give us m1r by 4 divided by 3m1 by 2, which gives us the answer as r by 6. So the answer is r by 6. Question 11 is good. It says that two particles A and B of equal masses have velocity VA 2i plus j and VB minus I plus 2j. The particles move with acceleration. The acceleration of A particle is minus 4i cap minus j cap, and for B it is minus 2i cap plus 3j cap respectively. Center of mass of two particles moves along, so we have to tell the shape of the movement of center of mass. So for solving this question, we will use the fact that an object moving under constant acceleration will follow a parabolic path unless the initial velocity and acceleration are parallel or the initial velocity is 0. So what I am saying is that if the initial velocity is not equal to 0 or the initial velocity is not parallel to the acceleration, then if there is constant acceleration, the path will be parabolic. So let us prove this. The acceleration will be somewhere in this direction, in any random direction, and since the velocity is not parallel to acceleration, velocity will be here, initial velocity. So I am choosing the coordinate system in such a way that makes my proof simpler. So I am choosing y coordinate parallel to the acceleration and x-axis perpendicular to the y-axis. So we can see that acceleration is only in the y direction. So acceleration will be aj cap, and initial velocity will have two components, right? v0 x and v0 y. Now since there is no acceleration in the x-axis, so the x coordinate at any time will be given as v0 x multiplied by t, and y coordinate will be given as v0 y t plus half at square. So from here to find the path of any point, we need to eliminate the time component. We only need x and y in the equation, right? So I'll eliminate time using this. So time will be x by v0 x which will give us that I am putting this time in the y equation. So v naught y multiplied by x by v naught x plus half a x square by v naught x square. So this is the equation of a parabola, right? And notice that v naught x is not 0. This matches with our equation that if v naught x is 0, then this equation is not possible, right? So now let us see what will happen if v naught is parallel to acceleration. If v naught is parallel to acceleration, then v naught will also have only y direction component, right? Because acceleration is in y direction. So x coordinate will be fixed and the motion will only be in y direction, right? So this means that the equation will be straight line because motion will only be in y-axis direction, right? The equation will be straight line. Also, if v naught is equal to 0, then also motion will be in straight line. You can easily prove all this. Okay, so now let us solve this question. So the velocity of center of mass, which will be given by VA plus VB by 2, comes out as this, and acceleration of center of mass, which is given by AA plus AB by 2, comes out as this. So VCM is equal to I cap by 2 plus 3 by 2 J cap, and acceleration of center of mass is minus 3 I cap plus J cap. So you can see that these are not multiples of each other, so they are not parallel. So trajectory will be a parabola. Since initial velocity is not 0 and this is also not parallel to the acceleration. So this was a nice question. Another question based on the same concept is this, that a body of mass 1 kg moves in the xy plane under the influence of the conservative force. Its potential energy is given by 2x plus 3y. The body is at rest at 2, minus 4 initially. So the quantities have SI units, therefore the body. So let us see if it will move in parabolic path. So we know that for conservative forces, force is given as minus du by dx, right? So force will be minus 2 I cap minus 3 J cap, and acceleration will also be same since mass is 1 kg. And since initially the body is at rest, so v naught is equal to 0. So that means if initial velocity is 0, then we saw that it will move in straight line and not in a parabola. So option A is wrong. It moves with a constant acceleration, yes. So now let us analyze the option C. It says that the particle will never cross the x-axis. So the initial y coordinate is negative and the acceleration is also negative. So the particle will increase the y coordinate in the negative direction only, and it will never come upwards towards the x-axis. So option C is also correct. Now analyzing option D, we need to find speed at t is equal to 2. So Vx will be given as, since u is 0, so at minus 2t, and Vy would be given as minus 3t, right? And V of x at t is equal to 2 is minus 4. Vy at t is equal to 2 is equal to minus 6. So the speed will be the vector addition, which is 16 plus 36. So this gives us 52, root 52, which is 2 root 13. So option D is also correct. So question 13 is also a very nice question. It is based on variable mass systems. It says that rocket fuel is capable of giving an exhaust velocity of VREL 2.4 km per second in the absence of any external forces. So we are asked the fuel required per kg of payload to provide an exhaust velocity of 12 km per second to the rocket. Okay, so the equation that we will be using is this, that the change in velocity is given as vrel multiplied by ln of m initial by m final, because after the fuel is ejected some mass will be lost and that will increase the velocity, and that is represented by change in velocity. So how we derive this formula, let us see. So this is derived using conservation of momentum, and when we write the conservation of momentum we need to know the final velocity and initial velocity of every part of the system, right? In this case, the final system is the rocket plus all of the fuel that it is having and all of the fuel that it has lost in the space, right? So initial velocity, the momentum is 0 since rocket is starting from 0 and rocket has all the fuel inside it. Final state is that the rocket has a final mass mf and a final velocity vf, but the velocity of ejected fuel is very difficult to calculate if we are looking at only the initial and final state, because the ejected fuel does not leave at the same rate, same velocity, right? Because here we have been given v relative. So we know that how the velocity of the fuel is varying as a relative function of the velocity of the rocket, right? And the velocity of rocket is changing at every point. So if we only look at the initial and final states, then we don't know how the what is the velocity of the fuel ejected, because the first puff of exhaust is pushed out when the rocket is moving slowly. So relative velocity will also be very small, right? And the last puff is when rocket is moving at a high velocity, because after some amount of fuel has been ejected, the velocity will have high velocity, and relative to that the fuel will be ejected at high velocity also. So all the fuel ejected does not have the same velocity and it has different velocities, right? So final velocity and final and initial states cannot be compared for momentum conservation. We have to use the calculus based method and look at every time interval dt, right? Because we can write the velocity of fuel ejected since we know the velocity of rocket at time t and dt, right? So instead of looking at the messy final state all at once, it analyzes the process incrementally. It looks at one tiny piece of fuel dm at the exact moment it is ejected, right? Because if dm is ejected, it will have some velocity, right? And only dm has been ejected, no other velocity, no other fuel has been ejected which has some other velocity. So let us see. So initial condition is that rocket is moving with velocity v and the mass is m. So I can write that p before is equal to mv, and now I will look at the final state. So the final state is that some fuel has been ejected. Let us say that it has velocity vrel because that is what we have been given, and it has mass dm. So mass has been subtracted from this rocket, right? Because the fuel was initially inside the rocket and now it is out. And the velocity must have increased because the mass has decreased. So lighter object will move faster. So rocket momentum is how much? Rocket momentum can be written as m minus tm multiplied by v plus dv. And fuel momentum is so what will be the fuel momentum? It will be dm multiplied by velocity of the fuel relative to ground in ground frame, right? We cannot write this equation in ground frame and this equation in relative frame. So we need to find the velocity of fuel in ground frame. And we know that vrel of fuel with respect to rocket is given as the velocity of fuel with respect to ground minus the velocity of rocket with respect to ground. this formula we know. So from here we will get that velocity of fuel with respect to ground is equal to the relative velocity of fuel with respect to rocket plus the velocity of rocket with respect to ground. And since we are taking this direction as a positive direction, so, and velocity of rocket is also in this direction, so I will say that the velocity of rocket, so this vrel will be relative to the velocity before this v plus dv, right? Because the vrel has been ejected before this became v plus dv. It was ejected when this was v. So I will write velocity of rocket as v, and the relative velocity is in this direction, so minus vrel. So finally the fuel momentum is dm multiplied by v of fuel with respect to ground, which we found out as v minus vrel. So equating, so p after finally, so the final velocity, final momentum will be the rocket momentum plus fuel momentum. Right? And we have to conserve the momentum. So P before must be equal to P after. So equating, P before was mv and P after is dm multiplied by v minus vrel plus rocket momentum is m minus dm multiplied by v plus dv. So opening the brackets, we will get dm multiplied by v minus dm multiplied by vrel plus mv plus mdv minus dm multiplied by v minus dm multiplied by dv. Now minus dmv and plus dmv will get cancelled, and also this dm and dv both are incremental terms, right? So dm and dv multiplied will become very small in respect to the other components. So this will also be 0, and now this mv and mv will also get cancelled. So we are finally left with dm multiplied by vrel is equal to mdv, and rearranging we will get dm by m is equal to dv. Now the rate of change of this mass is negative, but rate of change of velocity is positive, so there we must add a negative sign so that both sides can become positive. So this will be minus vrel dm by m is equal to dv, and now we integrate this from m initial to m final and v initial to v final, which will finally give us that delta v is equal to vrel ln of m initial by m final. So now we use this formula. So delta v is given as 12 km per second because initially the rocket is at rest and it is attaining exhaust velocity of 12 km per second. So delta v is 12 km per second. Relative velocity is given as 2.4 km per second, and ln m initial by m final. So we will get that 5 is equal to ln m initial by m final, which gives us e raised to the power 5 is equal to m initial by m final. Now the initial mass will have both the payload and the fuel. So mass of payload plus mass of fuel, and the final mass when all the fuel has escaped is only mass of payload. So E5 is equal to e raised to the power 5 is equal to 1 plus mass of fuel by mass of payload, and mass of fuel by mass of payload is what we have to find, right? Fuel per kg of payload. So this will be equal to mass of final by mass of fuel by mass of payload is equal to e raised to the power 5 minus 1, which gives us the answer as 147.4 kg. So this was a nice question. If you have not solved variable mass systems before, this is how you solve it. Now moving on to the last question. A wedge of mass m, capital M, rests on a frictionless surface. A block of small m starts sliding down. So we have to find out what will be the motion of center of mass. So since the net external force is only in the y direction, so the center of mass will only move vertically with increasing speed since acceleration is there. So option D will be correct. So this was the chapter center of mass and NSEP PYQs. Some questions were very good and there were some easy questions also. Let me know if you like this video and if you have any doubts. Don't forget to check out the Drive link and also join the Telegram for further updates. Like and subscribe. Bye.